Hey, my name is Chris Anders. I'm the Director of Customer Reliability Engineering. This is the team that does the development for the Troubleshoot project, which I hope you're familiar with. Also, if you select that you're opening a support case for the curl or embedded cluster product, you very likely talk to this team. It's a team with a lot of day two operational expertise. I want to talk to you today about some of the new tools and features we've developed for Troubleshoot, because sometimes just having these features doesn't make it clear why they're valuable and how they're useful. So I hope by showing you some of our favorite features, but also how we're using them, it will help you understand how you can apply them to your teams and your products. While we were developing these features, there were a couple of primary goals. First of all, we strive for a great user experience, both for the end user with the problem and our own team that need information to solve it. It's very frustrating on both sides when you don't have the information you need to move forward. We also want to learn from errors and quickly recognize when an issue has already been seen before. So some of the things we focus on to get there include, if we ever have to ask for more information, we always ask how we could improve our collection in the future so we don't have to go back for a second dip the second time. We also want to shorten the time to value from the time we learn something to when we start benefiting from it. I want a problem solved today to make analysis tomorrow easier, not next month or next quarter. I'll review some of the tools and highlight some of the features we've developed to help meet these goals and show you how we use them. It's all open source. You can see what we're doing directly on GitHub, and I'll have links throughout the presentation so you can see full examples where they don't fit on the slides. So while I hope everyone has seen the Troubleshoot project, I do want to give a quick introduction to it, since much of what we're talking about today are tools or features that work specifically with Troubleshoot. Troubleshoot is a tool to allow developers to define in code what information they need to understand the health of their application. Troubleshoot collects that information for the end user, allows you to redact sensitive information, and can analyze what was collected for common or known issues. If you've ever opened a bug report on an open source project, especially the larger ones on GitHub, you'll notice they ask you to fill out a form a lot of times with 4 or 5 different questions. They want you to go gather log files. They give you commands they need you to run. They ask for version numbers. And until you fill all that out, they'll mark the issue as incomplete, because they just have more issues than they can have sort through, and they need that information to get started. If you've seen that process, that's the problem Troubleshoot solves. Rather than providing a list of things a user needs to do, you provide a spec that defines what Troubleshoot needs to do. The user just has to execute it. The outcome of this is collected into a tar file that I'll refer to as a support bundle. All right, I want to start talking about an introduction to a cool tool called SBCuddle. It stands for Support Bundle Cuddle. And it's a tool that lets you interact with the collected resources from a support bundle using kubectl, the same way you would if you had access to the cluster directly. You can find the SBCuddle project on GitHub. It's a single binary, and install instructions are available on GitHub, or you can use the crew package manager. The reason I want to start with this tool is because it is extensively used here at Replicated. SBCuddle is the first tool I use when looking at any support bundle. It's proven to be so useful that you'll find work on the Troubleshoot project to start integrating SBCuddle into Troubleshoot itself, so that you won't need a second tool in the future at all. A support bundle captured by Troubleshoot has a lot of good information in it. However, easily finding and reviewing that information can be just as important as having it. I'm going to do a quick demo because I find seeing SBCuddle in use explains what it does far more intuitively than any explanation I can give. So this following demo is going to use an alias SBC. The alias is just a shortcut that I use to launch SBCuddle with the shell command and provide it my vendor portal access token. This makes it so that I don't have to leave the terminal, and I can get right to work understanding the state of a cluster. The alias I'm using with my token redacted is shown here on this slide if you want to use something similar. So let's take a look at that video. So I'm going to start just by demonstrating that there's no trickery here. I just opened a terminal to record, and I've got some other cluster already up and running in the background before I even started the process. This is the alias I just talked about. You'll see the SBC alias, and I'm going to give it a link to a vendor portal support bundle that one of my team members has uploaded. This URL that you see, it's a shareable URL from vendor portal. This is available for every support bundle you upload. I don't always know if people are familiar with that feature, but it's a fantastic way to share information across your team. It's much easier to provide a link in a bug report or in Slack to your users rather than trying to mail around the support bundle, and then everybody can access the same bundle in the same location. You'll see after I set this back up that SBCuddle is going to download the bundle into a temporary folder. This is using the API token I provided, so I don't have to launch a browser and go download the file myself. Next, because I use the shell command, you'll see I get a new prompt because a new shell has been created for me. In this new shell, the cube config has been set to the temporary file location. I haven't typed anything you see here after the SBC command. It's all automatic so far, and I'm left back at my command prompt. But this time with a working cube config for an API server that's using the support bundle I specified as its source of truth. So at this point, I can get nodes, pods, namespaces. This isn't the cluster you saw at the beginning. I'll let that run. Of the demo, we're looking at the cluster as represented by that support bundle. I can quickly understand what the cluster looks like, what's running, and the state of everything. This is much more intuitive and therefore faster for engineers that are already used to working with kubectl to get the state of a situation and look around and see what they need to know. Now, I can also get log files, and I've paused it here for just a second because I want to demonstrate. You may have noticed I'm using K. It's another shortcut instead of kubectl as I interact. That's because I have aliases and auto completions. Well, when I go to get the log files, which are also in the support bundle, you'll notice that I get prompted through an auto completion because it works just like it does when I'm talking to a Kubernetes cluster because I'm actually using kubectl. Finally, I'm going to exit the shell that SBCuddle was running in, and you'll see that my previous shell is unaffected. I can return to whatever I was doing. Great. Let's talk about what we just saw in that demo for a second. So with the SBCuddle tool, support bundles become virtual clusters that users can explore using the tools they're already familiar with. Collecting a support bundle gives you a snapshot of the state of a cluster that you can explore later. Having a point-in-time snapshot is great to demonstrate a failure condition on a bug report without a developer needing to reproduce it themselves. Some bugs are hard to reproduce. You only see them intermittently, and capturing the issue at the point of failure may be critical to ever understanding what's going on. Finally, one of my favorite but often overlooked uses is including support bundle collection in CI and CD pipelines. Here's a short example of how easy it is to use Troubleshoot as part of a GitHub action. The binary is installed, the bundle collected, and the results uploaded as an artifact of the run. If you want to see the whole GitHub action in this example, I've included a permanent link to it. It just doesn't fit on the slide. If you've ever had a CI failure that you can't reproduce in the instance that ran, it's ephemeral, so it's gone, then this is a transformational way to work with your CI pipelines. Now that you understand how we use support bundles, I want to talk a little about some of the features that make it easy to collect the information you need. All right, the first feature is a feature in Troubleshoot that I refer to as updatable specs. This feature was developed to help address the speed at which your teams can react and share information for support. If I boil the problem statement down to its most simple form, it looks like this. You don't know about bugs when you ship your software, or I hope you don't. Once you learn about a bug, waiting for your users to update so your support bundle spec can be updated is problematic. Even if your users update their software every week. We started by saying we wanted a process that allowed a bug found today to be identified by a team member that sees it tomorrow. It's still not fast enough. Updatable specs is a feature to help you improve your support process at the speed of learning rather than the speed of customer updates. By providing a source of truth to any support bundle, Troubleshoot will check with that source of truth and use the newer version if it's available. This ability to update at runtime decouples the speed at which you improve your collection and analysis process from the speed of your releases, or more critically, your end users' update cycles. Let's take a look at what it takes to enable one of these in your support bundles. So you'll find information about this on the Troubleshoot documentation at the link I'm showing here. This is an excerpt from that documentation that demonstrates it. Here you can see that the spec includes a top-level key, URI. That key is specifying the source of truth for this specific spec. If you look at this URI, you'll see the example comes from a spec we use here at Replicated. The URI, in this case, directly points to a GitHub repository where we revision and update the spec. This lets us serve our latest spec directly from GitHub. As the team identifies new learnings, we open pull requests, review them, and they go live as soon as they're merged. While we're linking directly to a spec in our main branch, you could easily revision your spec in other ways to track the lifecycle of your application. Just remember that Troubleshoot is designed to fail forward. It's not strictly necessary to remove a deprecated part of your spec just because you've removed it from the most recent version of your application if some of your users would still benefit from it. This means our spec is always using the most up-to-date information from the team, even with a globally distributed team of engineers. The one caveat here, of course, is offline or air-gapped environments may not be able to access the URI you've provided. Troubleshoot fails gracefully. If it can't find the source of truth, it uses the bundle as provided. So you're no worse off for air-gap environments. By including a URI in your support bundle specs, you leave yourself the opportunity to utilize things you've learned immediately, regardless of if the user is updated, your documentation might be out of date, or any number of other reasons somebody might have an old version of your spec. Here at Replicated, this fast feedback loop encourages continual learning and sharing across our teams. As I prepared this presentation, I checked, and it's been 2 business days since it was last updated, and I won't be surprised if it's changed again by the time we get done with this presentation. That wraps up updatable specs. We'll talk about how this combines with some of the other features in a minute. For now, I'd like to talk about a collector that's frequently not known. Host collectors are frequently missed in Troubleshoot. Troubleshoot is primarily designed to gather information from Kubernetes clusters. However, there are times that it's still important to collect information that's not related to Kubernetes. While the in-cluster collectors communicate with Kubernetes, the host collectors run directly from the host. It doesn't require Kubernetes to be running at all. If you have raised a support request for a down or problematic cluster with our team, you've probably been asked to run our host collector-based support bundles. In fact, I have some vendors who have become so aware of this process in a situation where a single host seems to be behaving differently from the others, they'll just go ahead and run the host collector spec from the impacted node and include it with the support case. Anytime we would need to ask a user to run commands to understand the state of the system, we try to default to providing a support bundle with host collectors. Understanding the state of a Linux machine is not a single command process, and each of these commands might have a few flags and options to get it to show you the right information you're interested in. In the Unix philosophy, do one thing and do it well. Troubleshoot lets you combine all those highly specialized tools and configure them with the right options to give you a quick way to gather the information you need to diagnose problems on the system. So let's take a look at an example. The link shown here is our current host collector spec. I've shortened it quite a bit for this presentation, so feel free to browse through our spec for examples of how we use it. Here are a few things that I've selected to show today. First, you'll notice we're using the URI field previously discussed. All of our specs use it. If you're familiar with in-cluster collectors, the spec should look very familiar. Defining collectors and configuring them uses the same format that collectors are available. They're just done on the host rather than in Kubernetes. You'll see we gather information on block devices, disk usage, and we use top to gather information on running processes. The last one shown here is netstat to look for open ports, which is particularly interesting. Netstat is one of those commands that always requires a long list of flags to get the view of the information you want. By putting it in a host collector, you don't have to constantly try to remember that long list of flags, and your user is less likely to make an error when they're gathering the data. Data from host collectors are stored in the support bundle, just like the in-cluster data. You can view all of the commands that were run and their output in plain text inside the bundle. Host information can uncover some really hard to diagnose issues. The addition of netstat in our collector comes from the need to check and see which ports are currently in use on a system. One case that helped us identify was a pod that was failing to start on one specific host. It was later found that there was a user had another process running on that particular machine, which was already consuming the port that was required by Kubernetes. The end user didn't think to tell us about this process because they didn't realize it was related. Ensuring we have information like ports that are in use can identify otherwise very tricky failure conditions. Now that you're aware of both in-cluster and host collectors, you might be wondering if you have to ask the user to collect 2 different support bundles. That doesn't really fit in our goal to simplify end user experiences, and our next feature was developed to address just that problem. So in an effort to keep requests to the end user as simple as possible, Troubleshoot has implemented the ability to merge multiple specs at runtime and include them all in a single support bundle. Our team uses this in a couple of ways on a regular basis. The most common example is when you're unsure if an issue is related to Kubernetes or the host system. We maintain a spec for host collectors and one for in-cluster collectors, and we can ask a user to run both of them with one command. The example shown here is showing calling a support bundle and simply providing 2 different specs. You can keep chaining specs together and they'll be merged at runtime. Another example of when you might want to do this is if the default information is good and needed, but you also want to collect something new for a specific support case. You can collect your standard collectors and provide a custom spec tailored to whatever the issue is you're currently dealing with. If the information is useful, we'll consider a PR, make it part of our standard collection. This lets you try out new collectors immediately without having to stop and get a review until after you've finished with the case at hand. Finally, mergeable specs can be useful to help you organize your specs as well. With mergeable specs, you can manage a spec in the repo with the team that's most knowledgeable about it. Product teams and support teams can have their own specs to capture what they need to know. The examples we've been looking at so far are managed by the customer reliability engineering team, but there are specs maintained by product teams. You can even include our support bundles in your application as well and merge them with your application specific support bundles, making a superset of information we typically gather and information that's interesting to you. Allowing the definition of specs to split up across teams and knowledge domains is how you can leverage the distributed knowledge of your different teams. A database expert can define what information to collect about the database, while another service collects the configuration and interfaces important to it. As people move to microservice architecture, mergeable specs allows you to manage the knowledge however you structure your teams and organization. Now that we're talking about more than one or two specs, but possibly many specs from different teams, it's time we think about that end user experience again. No one wants to run a support bundle command with 12 microservice specs all in one command line. Pulling all these features together are in-cluster specs. In-cluster specs allow you to lever the specs that use all of the features I've just covered while shipping the spec as a manifest alongside your application. Today, you can use config maps or secrets to deliver the spec to a cluster along with your software and then discover the specs via label. Each microservice can manage a spec relevant to its support needs. Each spec can have a URI field and automatically update at runtime. The end user no longer even needs to provide a spec path at all. Just tell Troubleshoot to load specs from the cluster. This feature is also very flexible. You can collect all the specs from the cluster as shown in the first example here with no provided path. However, you can still use merging to provide additional specs just as I described before. The second example shows both in-cluster specs and a spec from the command line being merged together, again, creating a single support bundle. With in-cluster specs, the user gets the simplest possible experience. You don't lose any of the flexibility to combine one-off specs as needed, and one team with one spec or 12 teams with 12 specs are the same user experience. The decision is really up to you and what fits your organization and team structures. In case you're wondering, COTS will already search for in-cluster specs, enabling you to start using this feature right now with no requirement to ask the users to run Troubleshoot in the command line. I think we've covered some of the most important ways you can organize and start collecting data, so I'm going to cover one new analyzer today as well, so let's take a look at that. I haven't really spoken about analyzers today, and that's largely because you can get significant value from understanding how to properly collect the data you need quickly. Until you're collecting data, there's nothing to analyze, so I recommend you start by focusing on getting all of your teams the ability to specify what data they need and ensure your customers are providing that data. Once you have the data you need regularly available in support bundles, you're ready to further accelerate your problem resolution by sharing deep knowledge across the team with analyzers. This cluster resource analyzer that I'm showing today can be used to check any attribute of any known resource in the cluster in a generic manner. You specify the kind and name attributes and optionally a namespace to target a resource. The YAML path attribute shown here is used to specify a delimited YAML path of a property on that resource. The comparison can use standard operations for numeric values like greater than and equal to that you see here. There are also options for regular expressions and booleans shown in the documentation. This is an interesting example because of its flexibility. We're showing it here being used to check both the available size and it's being used to check the attributes of a volume. And it's doing this as part of a pre-flight. This was developed because it can be very difficult to ensure that your application is provided the storage it requires. There's no way to check many attributes of storage providers in a cluster. Verifying if you can allocate the requested size or check that the volume has the expected read-write capabilities can't be done by any common supported way on storage providers. So what we've done is we've spun up a pod and we're using this analyzer to check the pod itself. While this analyzer solves that particular issue by allowing you to inspect the volume, it's also a powerful tool that you can use to check any other resource and fields that you need to verify in pre-flights or as part of a support bundle during day 2. It's very flexible and it's quite new, so I want to make sure you're aware of it. All right, I hope this overview has helped explain why some of the features exist and how they can be used together. It's not always obvious the way in-cluster and mergeable and updatable bundles all go together to really enable your teams. Sometimes Troubleshoot is seen as a tool only built for support teams, but it's really quite a bit more. Every developer can and should define what critical information they need to see when something goes wrong, with each member contributing their knowledge to your automated issue resolution every member of your team benefits from the knowledge of even the most specialized individual. I often say we don't use knowledge bases here at Replicated, which seems strange to people because it's pretty standard support practice. This is really only partly true. What we're really building is a distributed knowledge base that proactively identifies the issues you need to be aware of so you can quickly get to the root cause.